Welcome to the lecture on clustering. So far we have studied the algorithms where you had a training set and you have to you have to predict some kind of class level for an unknown example. So, the number of classes are fixed beforehand and you have a training data which for a given input tells you that this would be the class and you train on that. So, this type of learning is called supervised learning. On the other hand, in some of the application it may be the case that we need unsupervised learning or exploratory data analysis. For example, suppose I am looking at customers in a supermarket, say Big Bazaar or something, and I want to find group of customers. I do not know beforehand what are the groups, but looking at the behavior of the customers, I want to find out the groups. And there are many other applications. For example, I want to group the images in the internet into similar things. So, the definition of clustering is you have to organize the data, the points, the examples into groups which are homogeneous. Homogeneous means if you take points from the same group, they are close, whereas you want to find if you take the points from different groups, they are apart. So, you want to maximize intra-class similarity and minimize inter-class similarity among the points. This actually amounts to finding the natural groups in the data, So, what does natural groups mean? So, suppose I have these images. Okay. So, if you note the previous definition, I said that you group your data into similar objects, similar. So, the term similar you have to first define before you define what is a group of similar object. Okay. So, that this similarity measure defines what is a natural group. For example, what is a natural grouping among these objects that I am shown in the picture. So, I can have several possible groupings. For example, I can have two groups, this 9 images, I can let us say all members of this family, these are people of a family and maybe some employee of the school. That can be a possible grouping, one clustering. Or I can say I group into male and female, that is another possible clustering. So, what is a natural grouping, what is a similarity is subjective. Okay. So, first you have to define what is similarity. Okay. So, naturally it will depend on the attributes of the or the features of the objects between which you find similarity. For example, here if you are looking at the texture of the images or the color of the images or the position of the eyes in the images, they are similar. Okay. But actually there is some other aspect in which they are not similar. So, it is a difficult task to define similarity, Usually, and once similarity is defined, that is clear. So, once similarity is defined, what we will do is the following. I will explain you with an example. So, for example, if I have two features and my data points are say and so on, and maybe there is another set of points. Note that there are no more class levels, and suppose two points. Okay, so you similarity between two thing is this distance. So, basically this similarity, then what I am trying to do is to find all groups which are close. Okay. So, to explain again, if I ask you to split up these points into two groups, you will never do like this. All right. Instead, you will do this group. Why? Because it or yes. Distances. Okay. In fact, there is a measure of how good the clustering is, which will prefer this cluster, these two cluster instead of this, is called scatter coefficient. Scatter coefficient. This is a very important term. Okay, it is the average distance. Okay. So, how do you calculate it? If I have points like this, and this is my clustering, you take all these distances. So, the average of all these take all these distances. distance. Okay. So, this ratio is scatter. Okay. So, given a set of point, given a partition into two groups, you can always measure the scatter and lower the scatter, better is the clustered. Okay. All right. So, let us come back to our discussion. So, basically we need some kind of distance measure between two objects, as I have said, dissimilarity. So, in general distances are complex. For example, how to distance between two images. Two images. How do you do? Maybe you look at the pixel values and see how much they are different. You can have two patterns. Maybe their shape, how does they match, and so on. Okay, you can have strings. How? Maybe how many alphabets are different. Okay, how many alphabets are different. Are different. Okay. Whatever value you take, you have to satisfy certain property for it to qualify as a distance measure, however way you define distance. These properties are called so you can define your own distance function, but you have to ensure that these properties hold. What is the property? Symmetric. That means, if you take 2 points A and B, the distance between A to B is same as the distance between B to A. Okay. Symmetric. Reflexive. So, this is reflexive means if you take the same point, the distance of a point to itself is 0. Is always 0, reflexive. All right. The third one is the triangle inequality. That means, if you take 3 points, if you take the distance A to B plus B to C, it is greater than or equal to distance from A to C directly. So, A B plus B C, in some cases they will be equal if A, B, C are in a straight line. Yes. This is the triangle inequality. Okay. So, this is the 3 properties you should satisfy. So, now using these properties, you have to group them, you have to cluster them. Okay. So, there are again two types of clustering. One is called hierarchical, step by step, one is called partitional, right. So, what is partitional? How will I do it? What I will do is given my points to be clustered. By the way, what is a partition? Is a division or grouping points into groups such that two things, point belongs to a group every point belongs to only one group. So, if I group it into two, this is group 1, this is group 2, let me call it cluster 1, cluster 2, every point falls in one of these two group. Okay. So, if a point is left out, it is not clustering. Similarly, a point belongs to only one group. In other words, you cannot have clusters like this, overlapping thing, cannot have. Okay. There is an alternate called fuzzy clustering, which we are not discussing, where it is allowed. So, relaxation of this only one group is called the fuzzy clustering. Whereas, this is called a crisp clustering. Right. So, what does partitional algorithms do? What it does, you have your points, you make all possible partition, this is a partition, this is another partition, this is another partition. What it does, evaluates each partition and compare them based on how good the clustering is. Okay. So, which will of course, to when you need how good, either you can measure by scatter or some other measure we will discuss later. Okay. So, it checks all this, it checks all the possible clustering and chooses the best. In this case, maybe this is the best. alright. So, this is partitional clustering. And alternate is hierarchical clustering. Okay. So, what it does is like this, it follows a policy of either split or merge. Okay. It does not try out partition. What it does, for example, okay, it will first try to make small clusters and say this is 4 cluster, then merge these clusters into larger clusters. Okay. So, you construct a tree, a dissimilarity tree or a distance tree. What you do in the tree? The tree looks like this. In the leaf, you have the individual points. Now, the tree merges these leaves, some order it merges these leaves, they keep on merging till everything. So, so what happens in the, what does margin means? This means these two are a cluster, this means these two are a cluster, this means these two are a cluster, these two, these two, these two. Then at the second level, these two are a cluster, these two are a cluster. So, this way at every level you keep on merging till everything gets merged into a single cluster. Okay. So, let me give an example. Suppose all the students, first I look who are maybe in same class, I group together, then maybe who are in the same department, I group together, then maybe who are in the same college, I group together, then maybe who are in the same state, group together, then maybe who are in the same country, group together. So, this is hierarchical clustering. There can be two approaches. So, see, this is what, that is what being done here. Clustering. Okay. So, there are two approaches. Bottom up, where you start from the bottom of the tree and then keep on marching. And finally, everything one. So, this is called agglomerative. Clustering, bottom up. Okay. Similarly, you can have top down. So, what you do? Initially, everything is a cluster, then you break them up into two clusters, then maybe subdivide. So, you construct the tree top down till you every point is a separate cluster. So, this is called divisive clustering. both are hierarchical. Okay. Both way you can construct. And how do you get the actual clusters from this? You cut this tree at certain level and say everybody in the left of the tree is 1, in the right of the tree is 1. So, that you can do either in agglomerative both. See, in both these clustering tree is constructed. Okay. Either bottom up or top down. So, this is all points and the leaf is individual points. This tree is known as the dendrogram. All right. So, I stop here today. In the next class, I will explain how this dendrogram is constructed in different algorithms. Thank you.